Okay. Thank you very much for your introduction. I didn't understand almost the words. I only understood something that is important for me, is that really 65 important people from the cultural and scientific world of Portugal wrote a letter to the dean, the major dean of the University of Porto, which is a big one, not a small one, and saying that the university must scrutinize the kind of information, the kind of conferences they do. So I should have been censored before doing the arranging all these people, these wonderful people that met in Porto, and the dean must know what they were talking about, and they cut their words because it was not the politically correct ideas to to say. So it was a very sad thing, but I survived, and I really think it was funny. It was funny, and it was mostly funny because a climatologist from my department, I told her, please come to this conference, it is related to you, so you must go. And she said, no, I'm sorry, I'm very busy these days. And of course, she signed the letter. After all, she signed the letter saying that I didn't invite anyone, but only the people that was thinking as myself. So it is a kind of, okay, I can't classify this thing. But let us begin. Thank you, Wolfgang, again. And our first purpose is to use the available data to criticize our enemies. Let us put into commas. Enemies is not really the real word, but it's okay. Use these arguments to demask them. Because, you know, we think, I have cats, I love cats, and I think that sometimes their ideas are like a cat with his tail off, a hidden cat with his tail off. I am going to analyze the permanent service for ministry level and the SONEL, which is the acronym is there. The SONEL data is a bit complementary what Professor Morner and Thomas Weissmuller had said. It's not the same thing, happily for you. You are not going to listen to the same thing again. But they have two things in their site, two things, the sea level trends and land movements. And it is interesting to analyze this. If I make a kind of chart with the position, latitude and longitude of the several tide gauges, we can also already almost see a map of the world. And you can see, but in the northern hemisphere, of course. In the south hemisphere, you have Australia and nothing else, almost, because there is a lack, a very big lack of information about the southern and the lower southern hemisphere and the lower latitudes. The GPS data are very interesting for us. I will explain it to you, and of course it's more than clear for everybody that what we find is the relative sea level and relative to the land. So if the land is moving, of course, the trends are modified by the land movements. And what we can get in the SONEL site is not my information. I didn't invent anything. I only read the things they publish on the internet. And what we can see is that almost all the areas in the littoral zones have or absence of movements, it's this, or they are subsiding. Most of the littoral areas are subsiding, so there is a consequence of it. Of course, the sea level trends must be exaggerated. They are not the real ones, they are bigger because the land is sinking, yes. So in these sites you can see two parts of it. You can switch from relative sea level to absolutely so-called geocentric. It's a kind of combined trend with sea level changes and the GPS changes. And you can even switch from several data. So it is the kind of way of organizing your analysis of these sites. And if you see the map, you can see that you see the legend here. There are places where the sea level is going down, the absolute sea level, as they consider it. It means sea level trends plus land movements is going down, of course, in the areas in the north, and places where it seems to be stable, and, well, most of the places it seems it's going up. But you can see that most of the places are in yellow or a little light orange, so less than 2 millimeters per year, okay, of absolute sea level change. Their data, not mine. There is a place that is in Antarctica, also with a red arrow. It means more than 4 millimeters of absolute sea level. They say, so they say. Let us analyze the places where the sea level changes seem to be more than 4 millimeters per year. It means some of these areas and these areas too, okay? And these are the only stations. There are 7 stations all over the world in this condition, okay? You have seen the arrows, the red and the brown arrows. So let us analyze. It's a little tedious maybe to say everything to you, but in the Alaska, for instance, you have, I must see this here, a combined velocity of 10 millimeters, but this data is taken from a place which is 10 kilometers from the tide gauge, okay? So what is the meaning of a GPS which is 10 kilometers from a tide gauge? Nothing. And also in a place which is, we know, it's uplifting, so it's not a stable place, not in the world. Okay, so Antofagasta in Chile, well, there is another place with a brown arrow. Sea level is going down, but land is uplifting very much because there was a big earthquake there. But nevertheless, they say that the combined velocity is here, and so that sea level is, absolute sea level is going up. Another place, Palermo, Argentina, and is something similar, not similar at all, I'm sorry. But sea level is going up, of course. The GPS data gives this curve, not very stable, but also another thing of the same kind. The distance from the GPS and tide gauge is more than 7 kilometers, so the meaning is Argentine islands, in the Antarctica. What we have, you have an interesting thing also here, because you have a curve with all the data they have, and the trend, which is quite big, 3,5. But if you split this data, you have a very different trend. So it's very important. It has been said before. It's very important to study the right numbers. And these are clearly not right. These first data are completely wrong, of course. And also, the GPS is not very secure, I would say, doesn't give a very good results. Going to Europe, what we have? You have 2 places with red arrows, which is Cadíz in southern Spain and Klaipeda in Lithuania. Okay, about Cadíz is an interesting thing, because really the trend, we can find that permanent surface from sea level is that one, okay? And then, really, the GPS shows a kind of stability. And then, again, what we see is that the distance between the GPS and tide gauge is more than 10 kilometers. And you see what tide gauge is in an island, so it, of course, is not stable. Of course, this doesn't mean nothing. This combined velocity that they find means absolutely nothing. In Lithuania, of course, you have these cycles that you can see in the sea level changes, and of course, the most recent data, they give a bigger trend, but same thing about GPS. So they use this data, what I'm trying to show. They use this data. Individually, trends might be correct. Individually, GPS might be correct. But sometimes, most of the times, there is one thing wrong in these equations, so the result is not right, is incorrect, of course. That's what I pretend to say. The only place where there is, and of course I can't explain this, I was never in Japan, but where there is a sea level rise here, as the tide gauge say, 3.5, and also a land uplifting, which is puzzling for me, is in Japan, but is the only place. And here you have a kind of summary of all these 7 stations, the only one that were painted in red or brown. So the only one that were puzzling and with more than 4 millimeters per year of absolute sea level rise. What about Iberia? Okay, it's my land. Unfortunately, most of the tide gauges, mostly in Portugal, and I'm ashamed of that, they are not actualized. You see, in Spain they are, but in Portugal they are not. There is an important thing in Iberia, is that it was compressed from the north and from the south, so we have mountains in the north and mountains in the south, and so you have neotectonics and earthquakes in the north, Pyrenees and Cantabrian mountains, and the Baeticus system. But also in the west, which is curious. You must remember there was a big earthquake in Lisbon some 100 years ago. And the sea level trends in the Iberia are like this. These are calculated by the permanent surface forming sea level. What you have in blue is the trends, and what you have in yellow is the number of years of the series. And what you see is that when you have a big series, like this one, you have, for instance, Cascais, is that one, and you have a trend of 1.3 millimeters per year, not much. The The biggest trends are in places where, of course, the number of deers is very, very small. Showing it in, and by the way, the Portuguese coastline is here. So very mild sea level trends. So if you picture it out, what you can see is that the stations, tide gauges with limited number of years, they have very large variations. And the ones with really big series, they have very small variations and not very big trends because they are much less than 5 millimeters. It's about 2 millimeters or so. Cascais is a place near Lisbon with the biggest series of sea level data in the peninsula and one of the world. Unfortunately, the data finished in the 1993 or something. It means the data that are involved in permanent surface for mean sea level because there are other data. And so you have the trend, the calculated by Excel trend, which is about 1,3 millimeters. And now they have digital tide gauges, and they are here, they are shown here. By the way, Cascais most of the time is not working well, which is just terrible. And there is a person, a professor of Lisbon University, that did this graph showing the trends in Cascais and showing that they are different from time to time, from 1880 till he can calculate them to the end because he got the other data, the other digital data. And what he says that the last years have more than 4 millimeters per year. In Lisbon, okay, in Lisbon, near Lisbon, where, but with these corrections, the corrections are an important thing, and Nicholas knows it very well. Because these things are removed. And to find this data, it was used an uplift of 0.5 millimeters per year, 0.5 millimeter per year. Was it an uplift at Cascais? It was not. There was no uplift at all. If there is something, Cascais is going down. A little bit, but it's going down. So, another thing, which is also interesting, Leixões is the harbor near Porto, my city, and there was a big work doing with digitizing all the tide gauges from more than 100 years. It's different from permanent surface for mean sea level, and they discovered that it seems that Leixões is also, the sea level at Leixões is going down a little. So you see the values? It was what they found. They are mathematicians. They are not geologists. They are not environmentalists. They are mathematicians. And so it is here you have the curve of Leixões. Of course, it ends before present. But you can see that even the curve that is there shows a kind of stability. Okay, Porto is not going down, sea level is not going up in Porto. It seems that, on the contrary, Porto, which has a beautiful landscape, as some of you must know, is uplifting, probably. That at least is my idea, because I studied the marine terraces there. Another thing very interesting I discovered lately, and I'm going to hand. I don't know what about the time, but at the NASA site, which is very useful for climate research, they have a new look. I invite you to see it. And here you have the Peninsula, the most important, one of the important stations is Lisbon, the Geophysical Institute, so it must be quite well done, we hope. And then what you have, a very interesting thing. The graph you see when you open the page is that one. But then if you click on an adjusted thing, you see this. And this is the homogenized data. And what you can see, what is the difference? Oh, it's a big one. You see, these points are around 998. It means El Niño. So it's a very hot year, really. And they make this disappear. It disappears here. And they make the hotter year, of course, the present one, 2017. So with this, they can, and they published now, before they published this kind of data, okay? And with this kind of data, you can do all the graphs you want. Now, they only publish the homogenized data. It was in a month or 2 months that this changed completely. So they put under the carpet the numbers they don't want us to see. Really, that's, at least it's my idea. And so, if you do a trend, a simple trend, I'm not a mathematician, on the Excel with the uncorrected data, you have this trend, okay? And Lisbon is one of the places in the peninsula where the temperature is going up, really. But this is the so-called corrected data, and the trend is almost the double, okay? So it's very useful for them to say that climate is really warming, and Lisbon is one of the places in the world where this is happening, and so the fires and everything is about climate change, and climate change, of course, has to do with CO2. That is the mainstream idea, and it is being sold all the time, every day in the TV and everywhere else. That's why my fellow scientists, some of them knew nothing about climatology, some of them were economists and sociologists and people like this, but okay, they really agree, they signed this wonderful letter to my dean. So it is really a hidden cat with his tail off. And thank you very much for your attention.